The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so we've talked about value stream and we've talked about process maps. In this module, we're really doing just one thing, which is to link those two together in what we call value stream mapping. Okay? And we're going to actually create a value stream map and look at we're going to demonstrate what some of these principles of analysis of the value stream map are and recognize some process improvement using value stream mapping. Okay, so this is the chart that's in the middle of your table. So let's go with this as the baseline chart. And now the question is, given that Sasha and Andy have a process map and they have the data, how can we combine the data and the process map to figure out quantitatively where we need to focus for process improvement? So value stream mapping is a very quantitative activity. It's going out and getting we heard Claudio say, go see for yourself. It's going out in whatever the production process is or activity is and actually getting data that can populate this process map. And once people have data, then they can make informed decisions. Okay, so we're on the second stage of the 5 stages of lean thinking, the value stream stage. Okay, so a value stream map is a tool. It's a tool to use to identify and eliminate waste. And I mentioned this, it's a map with process data added. And what kind of data do you add? You add the kind of data you need to improve that process. And here are some typical ones, but you don't have to feel you have to use all these data, use what's necessary. So usually times show up in there. Certainly if you have quality issues, you want to capture those. If you you may want to find out how much is in inventory. You might need to say how many people or space is being used. Another one that's often used is how far you're traveling. Okay, whatever is useful, you want to capture for your value stream map. And then here are the steps for doing value stream mapping. And again, you've already heard these, and this just writes them down what you've heard. You want to define what is value for your value stream. Then you create a current state map, an as-is map. So that's what we're going to do for Sasha and Andy. We're going to say, what is their current state? And they've collected the data for us. Then you want to analyze that map and see where's the value added and waste activities, and then brainstorm on how to eliminate the waste and add more value. And then once you have that, you create a future state map. You remap your process now where you think you can get to. And sometimes you might create what's called the ideal state, the best you can possibly think of. But that may be too big a step to take at once, and so you create the future state may be a step towards that ideal state. But you want to get a future state map. And then you have to have a plan for how you're going to implement that future state, how you're actually going to change the process. And we heard a lot about that at New Balance, how they actually moved things around, they reordered things, they trained people. On our tour, Walda said, we did a little step first. We didn't, we changed a little bit. We got started, and then we did a little bit more. So you don't want to break the system. Usually you're in the middle of a production while this is going on, so you have to keep reducing your units. Okay, so here's our value. Our customer value is they want good food, but they want faster service. So they're happy with the quality, but they want to get faster service. And here's our current demand, 50 customers and 100 hot dogs. Now, I've taken the data that's on here, the cycle time data, and just put it next to each of the boxes on the process map. And then the quality, we've also captured quality data, and so we have 10% rejects on this, but otherwise we're okay. Okay, so that's the kind of data you might see showing up on a value stream map. And now what we're going to do is take about 10 minutes, and the first thing we want you to do is to take some colored dots And on this map, just as a group, try to identify what these states are red, that is pure waste. There's no value being added at all. What steps are yellow, that is that they're not adding value in the eyes of the customer, but they're needed given the current process. Okay. And then what steps are green? What steps really contribute to the customer? So take about 3 or 4 minutes to do that, and you'll find out there's going to be some ambiguity. Okay, there's going to be some ambiguity. What's waste, necessary waste, and absolute waste. Just do the best you can. Okay, don't spend all the rest of the afternoon arguing about that. But then once you find out what's value add, non-value add, and the red is wait time here, fill in the blanks for the time, and also fill in how much time of this is allocated to Sasha, how much time is allocated to Andy, and how much time neither of them are working, because we're going to find out how hard they're working, how much of the time they're actually spending on executing this value stream. Okay, so go ahead and go to that, and I'll walk around and see if you need any help on that. And we'll then ask for your answers on these different times here. Okay, let's see where we're at. Like the last exercise, we got some Instructor Solutions to hand out to you. So how much time is allocated that neither of them are spending time doing it, but it's taking some time, sitting in wait or whatever? 63? Okay, that's good. Okay, was anybody able to calculate the total value added time in this process? No? Why don't we go ahead and hand out those sheets? Let's take a look at it. Okay, so this is one way of, what we have is 2 sheets. One is this slide, which is blank in your student notebooks, and the other is the worksheet you were working on. It's the same data, just shown 2 different ways. The instructors calculated that Andy's spending 224 seconds of the total of 446 seconds. And that Sasha's spending 159, and that 63 seconds, the order's just sitting there in the order in or the order out box. Now, what's value added time and non-value added? This is a little bit more subjective. The instructor solution was that taking order was value added. Now, you could argue, does Sasha need to spend 60 seconds taking the order? You know? Okay, okay. So, you know, that's questionable. But we booked it as value added time. But certainly that's an opportunity for improvement. You know, she is getting the customer feedback and seeing if they're satisfied and all that kind of stuff. But 60 seconds, you know, is a long time. Okay. We got 30 seconds that's just sitting there with nothing being done in the order in box for Andy. Then Andy's takes 100 seconds to cook 2 hot dogs. Okay, so under our current process, we'd say that's value added time. We're delivering that to the customer. Could he do it faster than 100 seconds? Maybe, but given the current process. But certainly the rework is non-value added. But now the question is that pure waste or necessary waste? Now we booked it as necessary waste because if we didn't check that order and it went to the customer without being properly filled, then it would not satisfy the customer's need. On the other hand, the customer doesn't really care about the inspection. So we added under the current process, it was a non-value added but necessary waste. But one could argue that it was pure waste. I mean, you could argue either way probably. Same thing here with Andy's wrapping up the bun. This is another thing where Andy's having to check, does he need to go cook another hot dog or not? Well, the customer really doesn't care about that, but on the other hand, if he doesn't see whether the order's complete, the customer's not going to be happy. So that's non-value added, necessary waste. Here it's just sitting there waiting with nothing happening in the order out, so we'll call that pure waste. And then Sasha does another inspection. Okay, that's an inspection. That's under our current system, that's a necessary waste because we don't have quality control working yet. We add the beverage, we deliver to the customer. Again, you could argue she doesn't need to take 30 seconds to deliver it to the customer. And then we booked this cleanup stuff as sort of, the customer doesn't really care whether the counter is cleaned up or not. On the other hand, we want to somebody's got to do it, so it's again non-value added but necessary waste. So that's how we booked it. Again, you could come up with different bookings, and we'd be happy to accept those, but you have to kind of make some decisions. So of that total of 446 seconds, the value added time's about 50%. Okay, that's not an unusual number. Actually, that's somewhat high for a first time through. But again, we could argue about whether some of these things are really true value added. About 32% necessary waste and 14% pure waste. Okay, so value added time's only about 50%. Opportunity for improvement. Okay, we should be able to do something better than that. Let's look at now the analysis part. So this is the value stream mapping. Now we're doing the analysis. We have a total available time of 240 minutes. So Sasha's working here, 159 divided by 60 minutes per hour times she services, that's per order, she services 50 customers. So she's working 132 and a half minutes out of the 240 minutes. So she's about 55% at capacity. She's got almost 50% capacity that she's just not doing anything. Okay. Andy's a little bit more overloaded. We got the 224 minutes times the 50 customers, 186 minutes total. I think I see a bug here. Huh? Yeah. Annalisa, can you note a correction on this chart? Okay. Anyway, this should be 186 over 240, which is 78% utilized. So Andy's working harder than Sasha. Now, what do we see here then? We have an imbalance. Okay, we don't have balanced work. We don't have them working at the same rate. Remember we talked about balanced work? Okay, what's the total capacity they have? Working with this current broken process, they should be able to service about 65, on average, about 65 customers a day. Okay? Okay, so that's an example of how you would do a value stream mapping and analysis. Okay? Okay, their tack time, we already computed up here, was 4.8 minutes. Okay, for 50 customers, they have to work at 4.8 minutes. Their cycle time is 446 seconds, which is 7.43 minutes. But remember that chart that had cycle time and balanced work, cycle time and tack time? So they got 2 employees, so they can both work in parallel. So that's why they can deliver every 4.8 minutes hot dog, because this is really divided by 2 because they're both working. Their production is okay. They're below their absolute capacity, but they got a growing demand. Both of them are underutilized, but there's utilization's not balanced between them. And this is a long time for making a customer wait to get a hot dog. Okay, 7 minutes. Okay, we should be able to shorten the cycle time. So in order to get through next week, Sasha and Andy are going to have to improve their process. Now we're just going to do this as a group, but what are some ideas how the utilization can be improved for Sasha and Andy? Yeah.
Sasha can take the next order while Andy's preparing.
Okay. Actually, she's doing that. She's taking the next order while Andy's preparing it already, and it's going in the order inbox. Yeah. Yeah.
Can pass the order directly from Sasha to Andy.
Yeah, get rid of the order intake, right? Okay, that's the only value added, yeah.
Sasha can do the fruit.
Sasha can do the fruit, right. That could balance the work between, okay? Yeah. Other ideas?
Andy could have more hot dogs on the grill than doing each one individually.
Yeah.
They're doing them in series, and they could be doing it in parallel.
Doing it parallel, yeah.
I mean, you go into Burger King, and you know how many they're cooking at the same time. Or, the next time you sit at the counter and watch somebody make pizzas, they got like 4 or 5 pizzas going at the same time.
Yeah. So they have anything like a Kanban system going here? You know, I mean, maybe Andy could be putting up hot dogs, and Sasha, you know, she takes the order, turns around, takes a hot dog, puts the fruit, serves the order, and Andy's maybe trying to keep her, you know, her box about full. Not over full, but about full. So they got this kind of convoluted process where and this is not unusual, by the way. This is the way often things, they take an order, they put it on a board, he takes that order, he does his thing, he puts it out, she does her thing, but you could be thinking more of like a Kanban approach where Andy's kind of looking out and saying, I'll try to keep 2 or 3 hot dogs up there at a time, or demands about that level. And he's in the back room cooking hot dogs, and she's serving the customers and filling the order.
Is there anybody, I just happened to come back from a skiing trip this weekend, and on the way up we stopped at Burger King, and on the way back we stopped at McDonald's, and there's a real difference, an industrial engineering difference between the way they do it. In Burger King, you form a sequential line, and you place your order, and you walk over here to try to pick it up. In the McDonald's, there's like 3 or 4 cash registers, and it's like a group rope. Everybody goes up to 3 or 4 of the cash registers, and it's a different process.
Yeah. Okay, so some things, let's eliminate this pure waste of things just sitting there waiting for some action. Let's get rid of this inspection. Let's balance the work between them. With a little bit of simple process improvement, actually using the tools you've heard about today, you could go in and probably triple their capacity, and the customers would be getting hot dogs, in 10 seconds or 20, 30 seconds or less than a minute. Yeah.
How do you account for how much the employees gets paid? Like, is there more value to having an employee that gets paid less working more, because then it's less cost? We're measuring everything in units of time, but isn't there a dollars and cents equivalent?
Well, there is a dollars and cents, but looking at, certainly from a lean thinking point of view, thinking about how I can reduce my labor costs as a starting position is taking the sub-optimization. What you want to do is look at how you can use those employees more effectively and get rid of the other costs you have or the other capacity problems you have, and reward your employees. So now, in the end, there is a limit to everything, of course. I mean, if you got $80,000 hot dog flippers, you're not going to be competitive. But look what we saw at New Balance. Those ladies up there are making shoes that are competitive in the marketplace, and they're not going to China. They're probably getting paid. What's the labor rate between the U.S. and China? 20%, factor of 20, at least. But New Balance is managing. It's a privately held company, so they're making money. Okay, and so thinking of just reducing labor costs as the first thing is not. It's just not a lean thinking principle.
Another thing that Earl's seen out there, we took one of the Arizona State team through the Apache production line, and we actually incentivize the employees to beat. They help schedule, but there's a schedule goal, a cost goal, and a quality goal. If they beat that goal and actually reduce the learning curve better than what we in fact put in the business plan, we share that underrun with the employees, so they're motivated to beat all 3 goals. And it's not just pushing out the door, it's got to be high quality or the Army won't accept it. So they have to beat all 3 goals, but those teams are self-managed, and they work. So you have to put the dollar incentives on the right things, and that's delivering value to the customer, schedule, cost, and quality. But you can in fact share that with the employees, and they're very motivated.
So a mass production thinking is that the workers are interchangeable cogs. And if we don't need them now, we'll get rid of them, and we'll go down to the job hall and hire more when we need them. And that they're just, and the lean approach is the workers are your most valuable resource. And let them help you make the system better and compensate them. Okay, we're about ready to wrap up this module. Okay, so we kind of quickly gone through the first 3 steps of value stream mapping. Obviously, we've kind of rushed it, but you've been through a cycle. Now tomorrow you're going to go through this again in a Lego simulation. Okay, so what would you do now where we're at? Well, you would say, Sasha and Andy would sit down and say, let's now that we have this data and see how bad our process really is, let's envision a much better process. And you would map that out, and then you'd go implement it. For them, that would be pretty simple. And you would do it, again, kind of taking the low-risk steps first. You don't want to break the system. Okay, so why is value stream mapping so useful? And boy, we heard about it today, okay? First of all, multiple people can visualize the whole process and see what the whole process is, as opposed to just their little piece. And it's really very hard to do without some visual tool. It's hard to describe, it's hard if you and I sit down and say, what do you do and what do I do? It's not the same as us collectively sitting down and building a value stream map. Then we really understand it. It's like active learning, it's internalizing it. Okay? You can see what the linkages are in the process. By working together, you develop a common language so you can communicate with your workers. And we saw up at New Balance how they, at least on our tour that Walda took us on, she said, if someone is missing for a day here or something, this person can step in and do their job because they understand what that job is and how that job fits in the overall flow. Okay? And then you can find out where the constraints are in the system. So it's, again, a system level thing. Find out where the constraints are and how that matches up against capacity and the wastes in their sources. So it's a very powerful tool. So finally, what are some tips? Involve everybody. This isn't something where you hire McKinsey to come in and do a value stream map and then give it to everybody because they won't understand it, okay? They have to do it themselves, okay? And it takes a little bit of time. Mark, it takes time. It takes them away from their job, but the payoff's usually much greater. You actually strap yourself to the process. You walk through it from beginning to end. Do it in some environment like this where you can move the Post-its around. You can collectively gather around as a group and look at this chart. And, you can put your Post-its here and you can all participate. It's a very flexible environment. At this level, a software tool is not nearly as effective as just butcher paper and Post-its. Now, if you're mapping the whole value stream of the 787, you're eventually probably going to have to get into some form that you can distribute. But as a starting point, you want to use something that's very simple. Use meaningful icons, agree on what they are, so that you're communicating with each other, and those are the basic steps. Okay, if you want to get more information on this, there's a book called Learning to See that really lays this whole thing out. This is really for factory-type operations like we saw at New Balance. Hugh McManus has created a version of that for engineering for what we call product development. Okay, so that's the value stream mapping module.